What's up guys, Coding Jesus here. Guys, this video is going to be the last of our three-part order book series in which we write a order book in C++ that supports multiple order types. Now guys, this video, while it is the last video, that does not necessarily mean that it is the least important. In fact, testing in software engineering is probably one of the most important things you can do to make sure your code is robust and clean. Now usually when I'm testing, I'm going through the test-driven development process. I write code, I test. I write code, I test. But for the sake of this series, guys, doing that would confuse too many people because I'd be jumping between various different projects, various different files, and I think it would add more confusion than it would actually help. So what I decided to do is make sure that this last video is focused exclusively on testing. Now, it's good that I'm making a video on testing because while writing these tests, and all this code's on GitHub, guys, so while writing these tests, I did notice that we had, I believe it was 2 dangling references, which is not good in any C++ application. It can cause a lot of problems. And so while fixing those are very simple, including them in our code can be catastrophic. So it's good that we're writing these tests. Now, before we actually jump into the code here and kind of figure out how we want to write these, not how we want to write them, rather actually go ahead and write them, we want to first figure out how we want to write these tests. So what's going to be our approach? Well, anytime I think about testing something in a more robust fashion, I often think about sourcing that information from another data source. In this case, what I want to do is I want to start in every test with a fresh order book. I want to hit it with incremental state, and then I want to compare the addition or accumulation of that incremental state against its actual final state. The way that I'm going to be going about doing this for the sake of both brevity and robustness is to be reading state or incremental updates from a file and then comparing it to that final result in that file, that final state in the actual file contained. So what it's going to look like is every row in a file is going to be an incremental update that I'm going to apply against the order book. And the last row in the file is going to describe what the order book state should look like. Now, that last line, what the order book state should look like, can be as simple or robust as you'd like. I could have made it very robust in this video series, but that would have meant that this video would be probably upwards of 3 hours, and people don't have the time and probably won't gain as much from the more robust approach than they would from the kind of more simplistic approach, which we'll be going through. That more simplistic approach will probably take an hour, so I'm hoping this video will be an hour or less. Now, what does that look like? Well, every line in the file is going to describe that incremental update. Add, modify, cancel, for example. And the last line is going to be the result that will specify 3 things. How many orders are in the order book, how many bids, and how many asks. Now, like I said, we could have made it more robust. We could have said in that final result line, what price is the final order? Or what do all the orders in the order book look like? That would have been a more comprehensive test because it would have really compared every single order in our order book to our desired end state, or expected end state rather. But for the sake of brevity, as I mentioned, I'm just going to be comparing 3 things. I'm going to be applying incremental updates and then comparing the count of the order book, as in how many orders are in it, and then in specifically the segregated bid count and ask count. So without further ado, let's get into this actual code. Okay guys, so what I did here to get this order book tests file that you can see here, if I run it for this very simple test, expect that, 1 equals 1, expect true. What I did was I went over here to my solution. I right-clicked. I went to Add, New Project. I searched for Google Test. I clicked on Google Test. I went Next, and then I just hit Create. Okay, I picked a folder and hit Create, and then I got my Google Test project here. As you can see here, this is actually highlighted in bold. And what I did is I right-clicked and clicked Set a Startup Project. So anytime I want to run this test suite, all I have to do is click on my local Windows debugger. Okay, now let's first consider a couple of files that we're going to need to include here. So we're going to need to include not only a Google Test, but we're going to need to include file stream because we're going to be reading our state and our final result from a file. We're also going to need to include IO stream. I think we might need that. Doesn't take away from anything. We're going to be debugging. And then we're also going to need to include, let's think of this, file stream, IO stream, file system. Yes, because we're going to be reading from files on our file system. Cool. All right, let's do a couple of things. The first thing we need to, obviously, because we're testing our order book, is we need to include that order book. Order book, YouTube. Cool. Nice. Now what I also want to do is I want to alias the testing namespace. I'm going to say Google Test equals testing. Okay, let's get rid of this one. And let's go ahead and start with our actual test schema and suite. So what do I mean by that? Well, I talked about what I want to do. I want to apply incremental updates, add, modify, cancel, and then I want to be able to get my final state and compare it to the state of the order book. Okay? So what I'm going to do is I'm going to say, well, my testing is going to involve a couple of actions. Okay? I'm going to be testing add, I'm going to be testing modify, I'm going to be testing cancel. Now, obviously, any of these pieces of information, or any of these actions rather, need some information that goes along with it. So let's create a struct called information, and let's tell the testing framework what sort of action this information is going to correspond to. So you can say type. I'm going to say order type, say side, price. I'm going to say quantity, and I'm going to say order ID. Cool. Now, what does this mean? Well, if I'm, for example, testing cancel, my type up here, okay, that is going to be cancel, and the only thing that's going to be filled out here, or the only thing that's going to be relevant, is order ID. If I'm testing modify, okay, my type is going to be modify, and anything related to modify here is going to be filled out. Anything that's not related to modify, it's just going to be left empty. This is kind of like a holder for our action or our incremental state application. Okay. Now let's also informations. Okay, let's actually also go into here and let's include. Cool. Nice. Okay, the next thing I want to do is because this information vector, or this information object rather, stores our incremental state application, now I also want to be able to define our result. So what we're comparing the final order book that has the incremental updates applied to against. So we're going to compare it against this result. So result, and like I said, this can be as robust or as simple as we'd like. For the sake of brevity, what I want to be able to do is test how many orders are in the order book and how many orders are on each side of the order book. Now, if my tests were more robust, what I'd probably do, including in this result, was I'd specify maybe a vector of orders and compare it against all orders in my order book, comparing their price, their quantity, their side, etc. But for the sake of this video and for the sake of being able to catch bugs quickly, I'm going to do simple tests. So okay, and then again using results. Cool. So now we have our inputs and our outputs. Now, I don't actually think I'm going to need this results vector because there's only going to be one result per test, so I'm actually going to remove this. Now let's talk about actually handling our inputs. So what we're going to need is a couple of methods and utilities in order to best handle our inputs and convert those inputs from a file onto an actual incremental update that we can apply against our order book. Okay, so let's go ahead and do that. So what do we want to call this? Let's call this input handler, I guess. Okay, let's start off with a couple of private utilities we're going to need. So the first thing we're going to need is being able to convert a string into a number, because things on the file are saved as and read from as strings. So it's a number. Let's use C++ 17 string view. Whoops. I think I'm going to need to include that as well. Let's just go ahead and do that. So cool. String view? Oh, wait. Am I? Oh, okay, that's why. This project is not C++ 20. Let's go ahead and apply that. Okay, that makes way more sense. There you are. Okay. So let's go ahead and get our number. Let's just default initialize it to 0, and let's just use from cars. That's where we store our value. And we're not going to store any negatives, so I don't want to worry about that. So I'm just going to say, I don't even think it would be able to parse negatives correctly, so I'm going to say logic error. Let's just tell people explicitly that value is below 0, and that negatives aren't allowed. Okay, now let's just cast this into our number. Cool. So that's our number. Let's actually make it a 64. Cool. Okay, now what I want to do is I want to write some code that's going to parse my result object. Okay, the way we're going to structure our result object is it's going to start off with the line is going to start off with a single character R, and all my incremental updates and all my results, those lines are going to be split by a delimiter. Now I can pick my delimiter. I'm just going to have it delimited on a space, so I don't have to type as many characters. Or not need to. A space and a comma would still be typing a character, but you guys get my point. I want the file to look as clean as possible. I'm going to place my result in here, and I'm going to return a Boolean if my result can not be found or can be found. So I'm going to say if the first character is not an R, because that's how you're going to know that this line is related to a result, then I'm just going to return false. Something went wrong. Otherwise, what I'm going to do is I'm going to say values equals split. I'm going to write a split function to split the string. And now I'm going to say, okay, well, result all, it's going to be my first item in my line, then my bid the first is always the result at 0, but the first actual like descriptive item. Cool. We're going to return true. We were able to parse that line. Okay. Cool. We're done this. So let's go ahead and now parse our information. So try parse information. Okay, now we know that the first character is always the action, whether it's an incremental update or a result. And then we know that everything after that is going to be very important pieces of information for us. Okay, so split string on a space. Okay, now what we're going to do in this test harness, as you've seen in what I've just shown you in the file, is I'm going to say, well, if the first character starts with an A, then it's an add order. Okay. Else, if the value is a M, it's a modify. Else, if the value is like C, it's a cancel. Else, oops, return false. Otherwise, return true. Because those are the only 3 actions that we're supporting. Okay. Now let's actually go ahead and implement these methods. So let's go ahead and do that. So what I want to do is I want to say, well, for this info, the type is obviously action type add. So our test harness will know that we want to apply an incremental add update. Then we will say info.side is parse side, and we'll write parse side in a second. Info.order type is parse order type. And as you can see here, guys, I'm always doing this in an order that makes sense to me. So side is going to be my first item, then order type, then price. But it's not just about it making sense to me. It's about it being consistent with the actual fields in the file. So if price is the third field in my file, I can't have here, 2. That doesn't make sense. That might be order type, for example, and it's not going to parse properly. Some of you probably paid very close attention and you're wondering why I have a black eye. It's because we're sparring quite intensively without headgear, and the other guy landed a pretty solid punch, but he couldn't take me down, which is what's important. And it was fun, but I have a little Medal of Honor here. Now, some people say, well, why don't you just film this video later? And when your black eye is subsided. Well, if you know anything about this channel, guys, we don't hide from our failures, okay? This is a coding channel, but it's also, in a sense, kind of like a level up channel, because we're learning and we're growing and we're figuring out how to actually become better versions of ourselves. So we don't hide out here. All right, now we're on the modify, okay? And like I said, just make sure that whatever order you want to give these parses, that they're consistent with the file. And then price. Cool. Then cancel is probably the simplest one, so type equals action type. Cancel. And then all we need for a cancel is obviously just the order ID, so we don't need to fill out the other fields. Cool. So we finished this function. Sweet. What we also want to first do now is, or what we want to do next is implement our split method, okay? We want to be able to split the string on our delimiter. So let's go ahead and do that. So obviously we're going to need to return a vector. And it's going to call a split. Delimiter. Okay, so what we're going to do is we're going to say, well, we need to first allocate this vector. We're going to call these columns, I guess. And then we're going to say, well, okay, let's just start at a start index and index. And let's go ahead and do that. So while x. Let's go ahead and find the next place we need to end at. And as long as the end index is not equal to the is not found, so as long as it's found, we need to continue. I'm going to say the distance between here and the end index is end index minus start index. I'm going to say our column is equal to the string substring of our start index for that distance, and we're going to say start index. Now let's increment our start index to one past that end. So end index plus 1, and now let's also store that result. So columns, pushback column. I think it makes more sense if I do it that way. Okay, now by the end of this loop, we're still going to have one column left. So what we want to do is you want to say, and by column I mean field. We want to say string substring start index. And this will take us to the end of the line. And then we want to return columns. Cool. We have our split. And now we just need to add our parse. Okay? Parse methods, parse side, parse whatever, parse this, parse that, parse order type, etc. So let's go ahead and do that. So start with side. if, as you saw in that file, b means by, so else if it's some other string, which we have no idea, unknown side. Okay. Next thing we want to do, order type. Cool. Good for day. It's kind of boring typing this, but you gotta write tests. Fill or kill. And hopefully this gives you some feeling of reward while writing this, because doing this from scratch probably feels good if you're new to the world of quant trading and you're really looking to learn. But I've written this. This is my second time writing this now that I'm filming it, so for me it's a little more like, oh, okay, mundane. Okay, I'll write this. You guys get it. Else throw logic error unknown order type. Cool. Let's parse the price. If the string is empty, let's just throw. Because we need to pass a non-empty string to this toNumber method. Okay. Do the same thing here. Let's actually just be more efficient about it. Let's go. Let's just paste this here. Let's just say, oh, it's the exact same thing actually, except it's unknown quantity. Okay, so I'll write it again. Cool. Order ID. And this is going to be the same thing too. So let's just go ahead and yank this. And let's jump back down. Whoops. Let's paste this here. Cool. And that's about it for our parsing. All we now have to do is actually be able to get this information from the file. Okay, so let's just pause here and go ahead and build. Syntax error, expected something somewhere. Oh, whoops, okay. Good call. Okay, builds. Okay, we're on the right track. Now let's make our public input handler, I guess, like a file reading method. So now we're going to put everything together. So let's return a tuple of our informations and our result. So the incremental updates and then the final state we expect. We're going to be using our file system. We're going to pass a path to the file. Okay, so we're going to have our informations. Let's just reserve a couple. I mean, we can have because we're using a file-based approach, you're going to notice that the actual code the code harness code is going to be very clean. Our files can contain up to millions of lines. So I'm just going to say maybe like let's reserve 1,000 here. So we pre-allocate some space. And then we're going to be reading lines, so let's have a line here, and then let's go ahead and have our input file stream, pass it our path, and then let's read the line. So while we can get the line from our file into line, let's go ahead and do this. So we'll say if the line is empty, well, then there's nothing else to do. Now, we have two cases. A line can either be an incremental update or it can be a result, right? So let's go ahead and differentiate those two. So we'll say is result. We know it's a result. Well, the only way it is a result is if the first thing in the line is an R. Otherwise, it's an action. Instead of saying action, let's just call update. I think that makes a little more sense. So if it is an update, then what I want to do is I want to pre-allocate the update. And I want to say, well, is it valid? It's valid if we can parse it from whatever line there is. So we're going to say line, update, okay, and if it's not valid, then we want to continue. Ignore this line. I might continue, I might actually throw here. It doesn't make sense to have an update that isn't valid in our file. So you can throw here. I'm just going to continue because that's how I wrote it originally. So I'm just going to go ahead and do that. So now we're storing our incremental updates. If it's not an update, well, then we know it's a result. Now results can only be at the end of the file, and I want to enforce that. So if our result is not at the end of the file, I want to throw an exception. Otherwise, let's get this result object and say is valid okay, if the result is not valid, I mean, when I originally wrote it, I did a continue, but that makes no sense at all. Actually, it does make sense if I throw an exception if it's not valid. So let me show you what I mean. So if it's not valid, I'm going to end up exiting this while loop. And if I exit this while loop, okay, I'm going to say, well, no result specified. Let's do that. Otherwise, if there is a result and we know that it's going to be at the end of the file, then I'm just going to return my infos and my result. So what this is saying is that the result needs to be at the end of the file. And if the result is not valid, we're going to end up coming here and throwing and saying no result was specified. So a continue here actually kind of makes sense. A continue for the incremental updates maybe doesn't make that much sense. So let's just go ahead and just throw a logic error saying invalid. And let's actually be a little more specific. Say invalid line. Invalid update for this line. Cool. So we're going to give the console the actual line that's invalid, so somebody that's looking at that line can say, oh, I see what the issue is. I see what the problematic line is. Okay? Now let's write our order book fixture. So what we're going to need is we're going to need to be able to read from a file, and we're going to be using Googletest to tell us, hey, run these tests and run them over this series of files. Okay? So the first thing that we're going to need is Orderbook Tests fixture. We're going to inherit from Googletest test with parameters. What's the parameter? The parameter is going to be a file, and it's going to be a const char star. Now, I also want to be able to specify kind of like where we should be reading these files from. And obviously, I'm not going to hard code a path on my own local computer because that won't work when you pull this code and try to run it. So what I'm going to do is I'm going to say inline. I'm going to say that my root path is my current path. Also, let's say static inline my test folder. So my test folder is going to be under, in this case, it's actually not under my my order book project, but in the checked in code it is. So I'm going to continue writing code as though it was. And we're just gonna jump to the actual written code after I'm done writing this with you guys, so you guys can see the tests in action. So my test folder is gonna be called test folder, and my location of my tests are going to be in system test folder path, and that should lie under my root. Now, like I said, guys, this project, as I made it, when I first created this little thingy here, I did not make it under the root of Orderbook. It should be under the root of Orderbook. So when I went here and I did add new project and I selected Google Test and I picked a folder, right? It asked me for a folder over here. It should be under Tomer source repos Orderbook YouTube. I just placed it under Tomer source repos because I already have that Orderbook YouTube folder with the tests project under it, and that would conflict. So let me just get rid of that. Cool. Now let's create our first test, okay? Let's create our first test. And we're going to focus on the arrange, act, and assert pattern. That's how I like to write my test. So test P, Orderbook tests fixture, and let's just call it Orderbook test suite. Okay. First thing I want to do is arrange my test. Where's my test going to be? My test is going to be under the test folder path, and I want it to be under, and I'm going to call it get param. Param here is going to be the name of my test files. What do I mean by that? Let's go ahead and actually see that in action. So param is going to return this. So to actually run these tests, I need to give it my test files, okay? And that I can either code or I can manually write. So I'm going to manually write a generator for it. Orderbook test fixture. Google test. So the values I want to pass are going to be match good till cancel dot text. Okay. Oops. I'm going to also have match fill and kill. It's going to be another test that I'm going to write. I'm also going to have match fill or kill hit. And a hit is a fill or kill that can actually execute, that isn't ignored. Then I'm going to have a match fill or kill miss test. That's a fill or kill that misses and nothing happens. I'm going to have a cancel order success test, because I can also have a cancel order failure test in which I try to cancel an order that doesn't exist. I'm also going to have a modify test that modifies the side of an order. And then I'm going to also have a match test for a market order. Okay, those are going to be my tests. Instantiate test case. Cool. Okay, let's go back to here. So what's going to happen is this test P test is going to be run for every file that I have in this method. All right. So now let's go ahead and actually complete this. So a couple of things I need to do. I need to actually get the file of interest, and then I also need to pass it to my input handler. And I'm also going to need to get my updates and my result. That equals handler.getInformation. Then I pass my file. And then I'm going to need to add a couple of utility methods. But before I do that, let's go ahead and do my act. So I want you to see what I'm doing first. So Orderbook. And what I'm going to do is I'm going to apply for every update in updates. I want to go ahead and switch on the action. So switch on what I should be doing. Okay. If it's an add, then what I want to do is, I actually don't even, I can just ignore the result. So I can say, well, let's just type it out. Right, Orderbook dot get add order. Add order, not get add order. And then here I have my get order. So here I'm going to be converting this update into an add order. All right, so this is where I'm going to add a couple of lambdas. I'm going to have order I'm going to be converting my information as written to on a file into an actual order that I can pass to my order book. Okay, I'm going to need right, that should all be specified in my add order. Oops. Cool. So let's go back to that. All right, we want to break. Sweet. Okay, now let's do my modify. So it's a modify. Okay. And once again, we need to write a conversion method that will take our information object, whoops, and convert it into an actual order modify as recognized by the order book. So we're going to take the information that was stored on the file, and well, what does a modify need? A modify needs dot order ID, side, price, quantity. Cool. Get order, what did I name it? Oh, get modify order. Okay. And now the final thing is cancel. Our final incremental update. Okay. Now what we need to do is, well, we don't need to write any like conversion lambda here to convert what's on file to some sort of object, because all a cancel need is an order ID. So I can just say, you know, update dot order ID. Break. And then if we have some weird incremental update that we don't recognize, unsupported update. Cool. Now we just need to do our assertions. So const auto. So what I'm going to do is I'm going to get all my order book info, so my internal order book state, and I'm going to compare it against what the result says that my order book state should be. So I'm going to say assert equals. So my order book size, okay, this should be equal to my result dot all count. So the count of all orders in my order book. I'm saying that my order book infos bid size should be equal to bid count get ask size equal to my result dot ask count. Okay. Now, this doesn't compare the details of that ask or those asks or that bid or those bids. It just compares that the amount of bids that I have are the amount of bids I expect. I could have made this more robust, in which case I would actually iterate over the bids and make sure that my results.bids object, I'd have to add that here, is actually equal one-to-one, bid to bid with the bids in my order book. That would have made this video a lot longer, and I don't think it would have marginally improved the amount of bugs I would have caught. So that's why I decided to include it. And we're done. Now, when you run this code yourself, what you're going to realize is first make sure it builds. Syntax. Oh. Values in. Cool. You're going to run this when you have these files in that folder. And you can copy these files off GitHub. And you're going to notice that there is some exceptions being thrown. That's because there's two places that bugs exist. So I'm going to go over that with you. So the first one's in Or well, I think they're all at here. Let's go to the easy one first. This one. Oops. This one. Okay? What you'll notice here is that I have a reference here. So I'm getting a reference to this data structures, internal order, and iterator state. Okay? The next thing I do is I erase the contents of that reference, essentially. I get rid of it. So now I have a dangling reference. All right? So to fix this bug, you're going to notice when you run the tests, by simply clicking local Windows debugger run, you're going to see that something goes wrong here. So just get rid of that. Get a copy to the pointer and get a copy of the iterator. The next one is in match orders. So if you scroll down here, and it's the exact same problem. Okay? I have a reference to bids and asks. Now, I don't want to get rid of the reference here because I don't want to make needless copies of those levels, which could be millions of orders long. What ends up happening is this code right here, bids empty, asks empty, okay? Because I erase the actual level, I'm erasing the reference to my bid level, this becomes a dangling reference when I iterate over this again. So you'll see this while loop, the second time around, the call to size is going to give you some outrageous number, okay? Because it's a dangling reference and it points to some random garbage. All right, so the way to fix that too is to say, well, I don't need to erase these while I'm iterating over the actual levels themselves. I can do that outside that loop. So I could do that right here. Oops. Cool. And those will be the two bugs that you'll find when you run these tests, okay? Two important bugs, simple bugs, but sometimes when you're writing code, they kind of slip by you. Now let's actually see these tests being run in action. So what I'm going to do is, I'm going to go here. I'm going to actually check out master. Cool. Now we are on master as on the GitHub, all right? The code is the exact same as we just went over. We have all our files here. We have our various actions. Okay, we have our handler. Everything's the same. Our test files folder is under our order book folder. Okay, and now let's go ahead and run the tests. So we hit run. Now, as you can see here, all our files, we have 7 files, they all pass. Okay, when you first run this, you're going to see some of them fail. They're going to fail because of the 2 bugs that I mentioned that I just showed you, which I also showed you how to fix. All right, so what really goes on here, if I put a breakpoint and I run this, as you can see, well, what file is this? This is the file. I'm not sure. You probably need to zoom in. The file's under users, tomers, source, repos, orderbook, YouTube, orderbook test, test files, match good till cancel.txt. That's the first test that we're going over. The first test that we're that's being fed here, which corresponds to the first file here. All right. And that's the end of the order book series, guys. If you would like to add more tests here, make the tests more robust, guys, the GitHub is public. You can go ahead and do that. Maybe you might want to do it as a little mini project and put that on your resume and say, you know, I worked on this order book project and I made the tests more robust or whatnot. Okay, this is the basis of the order book, but you guys can add to this if you'd like to make it as complex as you'd like. And if you go ahead and write something nice, you can submit a PR and have it merged into the repo. All right. If you guys would like to speak to me one-on-one, I have my Calendly link in the description and on top of this video here, calendly.com/coding-jesus. If you want to become a patron, if you appreciate me taking time on a Sunday to make these videos for you guys, you can become a patron. Patreon.com/coding-jesus. You get access to these videos earlier than everybody else. If you'd like to follow me on Instagram to see my life behind the scenes, to see, you know, I don't know, stalk me, do whatever you'd like, you can go do that at @thecodingjesus. Thanks for watching this video, guys. It's just under an hour, 50 minutes. That's great. Peace.